All right, the last rule that we're going to look at in section 5.3 is our multiplication rule. Our multiplication rule says if A and B are independent events, then our probability of A and B is the probability of A times B. Again, this is only true if they are independent events, right? So we do need to make sure that we're watching out for that. If the two events are associated, then we should use probability rule 5b, which we just talked a little bit about in one of our previous examples, and we can go through and test it that way. If we replace the probability of A given B with the probability of B for independent events, that's how we mathematically develop rule number 5c. So basically, we've just taken a previous version of this rule and we've replaced our probability of something being given by a single probability of an event. So again, this only works if we are looking at independent events. So we're going to go through and we'll talk about a couple of examples. Right, so roll a fair die, equal chance of each number 3 times. Right? Can we use the multiplication rule? So what we need to check is that these are independent events. And we are going to say yes, these are independent events. Independent events means one roll, right, does not change the next roll, right? So one event does not change the next, right? The probability of the next. So whatever we roll on the first one, it doesn't matter, right? If we roll a 1, doesn't matter. We have the equal chance of rolling something else or 1. Our probabilities haven't changed at all. Right, so since these are independent events, we can use our multiplication rule. So we're just going to multiply all of our different probabilities together. So what is the probability that all rolls are even? Right, so the probability of rolling an even number, well, that's 1 out of 2. Right, really it's 3 out of 6. Oops. Which then reduces to 1 out of 2. Right, half of our numbers on our die are even, the other half are odd. So 1 over 2 times 1 over 2 times 1 over 2 gives us 1 over 8. Right? Or we could write it as a decimal or a percent if required. Right? What is the probability that all rolls are the number 2? Well, we have exactly 1 out of 6 sides of the die that has a number 2. So 1 out of 6 times 1 out of 6 times 1 out of 6 is going to give us 1 out of 216, which is 0.005 or 0.5%. Right? Not a likely chance of that happening. What is the probability that the first 2 rolls are even and the third roll is the number 6? All right, well, even 1 out of 2 times 1 out of 2. Right. The last roll is the number 6. We have 1 out of 6. And then as we're going through, I probably should have mentioned this, I'm just multiplying straight across. 1 times 1 times 1, 2 times 2 times 2 is 8. 1 times 1 times 1, 6 times 6 times 6 is 216. 1 times 1 times 1 is 1. 2 times 2 is 4. 4 times 6 is 24. 1 out of 24 equals 0.042 or 4.2%. Again, we were able to use our multiplication rule because these were independent events. Our first roll did not affect the second roll. Right? And then what we're going to look at in the next one is we're going to, instead of rolling a die, we're going to look at flipping a coin. But they are independent events because one roll does not change the next. Alright, so for example 6, when we're looking at our coin flips, toss a fair coin, an equal chance of heads or tails 5 times. Can we use the multiplication rule? We're going to say yes, these are independent events. Again, similarly to rolling our coin, one roll does not change the next. So they are independent events, so we can use our multiplication rule. Right, so for B, we're asked which sequence is more likely? Sequence A, tails, heads, tails, heads, tails, or sequence B, all heads. Right, so let's work through and figure this out. Right, so we're going to multiply all of our probabilities together. So the probability of flipping a tails, 1 out of 2, heads, 1 out of 2, tails, 1 out of 2, heads, 1 out of 2, tails, 1 out of 2. We multiply all the way across. 1 times 1 times 1 times 1 times 1 is still 1. 2 times 2 times 2 times 2 times 2, 2 to the 5th is 32. Which gives us 0.031 if we changed it to a decimal. All right, now let's look at our probability of tossing all heads. Heads is 1 out of 2. 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 We actually end up with the exact same answer that we got for A. Both of them, relatively small chance. Which sequence is the more likely outcome? Neither. They are both equally likely. Right, the probabilities that we got, though they're small probabilities, are exactly the same.